Chapter 14, baselining and testing the network. All right. This chapter, what we do is we tend to kind of just go through some high-level discussion on how you should troubleshoot issues in the network. Now, as far as the default or the standard troubleshooting methodology, defining the problem is probably one of the most important components that you can do. Because what kind of problem description do you usually get by your end users? It don't work. It's slow. I tried to do this and it didn't work, right? So what do you ask yourself to define the problem? Did it work before? Did you change anything to make it not work? Or did you change anything at all? If it doesn't work, does it not work all the time? Does it work sometimes? You know what I'm saying? We call that, and I call that, when I teach my engineers how to deal with troubleshooting, I call that establishing the boundaries of the problem. You can't just do shoot by the hip troubleshooting. You have to identify the boundaries of the problem, which includes gathering information. Now, from the perspective of troubleshooting, gathering information, especially from the networking standpoint, gathering information might include, well, is it a physical layer problem? Is it a data link layer problem? Is it an application problem? And so on. Once you gather the information, you analyze that information, and you start to consider the possibilities. Now, I've already taught you guys throughout the first few chapters how to isolate problems or eliminate possibilities. Show IP interface brief, for example. If I see up on show IP interface brief, then I don't need to be troubleshooting the physical layer. I need to be troubleshooting the network layer. Okay? I mean, you guys deal with this all the time. This is not magic here. I'm not disseminating information here that causes an epiphany for you guys. Troubleshooting is troubleshooting. But I will say that the best thing that you can do with troubleshooting, any type of issue, is to set your boundaries. Eliminate the things that it can't be, because then that allows you to focus on the things that it could possibly be. Propose your hypothesis. Oh, I think it might be this, or I think it might be that. Test that hypothesis. Now, if that test involves changing configurations, or that test involves changing something, the general recommendation is if the hypothesis fails, revert back. Because now, if you change something and you don't revert back, you might be exacerbating the problem or adding to the problem instead of trying to resolve the problem. Also, you may want to do baseline comparisons. The network is slow. Okay, what do you mean by slow? Well, yesterday, when I downloaded this file, it took 10 seconds. Today, when I download the file, it takes 10 minutes. Okay? Swap components. If it's a physical layer problem or you believe that it's a hardware-related problem, swap components with components that you know work. Actually, I use this method all the time. If I'm in a data center and I can't get something to work, like maybe it's an SFP on a switch connecting to a fiber port, then I go to a switch that I know is working with the same type of SFP, and I'll swap out the SFP. If the problem doesn't go away, then I've eliminated that as a possibility. It might be a bad patch cable. Okay, well, give me a patch cable that's already working, one that's in the network right now that's working. Okay, is the problem gone? Hey, it was the patch cable. If the problem's not gone, it wasn't the patch cable. And then follow the path. Follow the path. Use tools like ping. Traceroute. Put yourself in the shoes of the packet and say, okay, if I'm a packet going from this computer, how am I going to get to where I need to go? What devices am I going to go through? Okay? Comment here. If the switch where you stole the SFP stops working, yes, okay. Don't steal hardware from stuff that's in production, but that doesn't mean you can't steal hardware from something that you've tested as working. All right? Troubleshooting is an art form, but in order to effectively troubleshoot your network, you have to understand how it works. And I think when you guys leave this class this week, you'll have a better understanding of how a lot of things work. You're not going to remember everything that I taught you this week, right? You've been through this class now twice, well, almost twice, and I'm sure you've learned things now that you didn't pick up the first time, but I taught the exact same class the last time, right? That's why we allow our students to take our classes as many times as they want for 24 months. Sales pitch, okay? All right? The paying customers, of course. All right? The part I never got my head around is that if you do an Nmap and it returns filtered, it is always, is it a firewall? What he's saying is I can use tools to scan my network for devices. I can use tools to what we call enumerate the network. Network enumeration means you're essentially trying to build a map of that network. And sometimes that enumeration fails because it's being filtered. A lot of the enumeration tools use ICMP to provide that function. And a lot of times devices will block ICMP. Windows Firewall, for example, will block ICMP if it's coming from a different subnet than the one you're a member of. Okay. Yeah, port tests using an Nmap. Nmap is a tool that we can use to do port scans and or software enumeration and whatnot. But just because a test fails doesn't mean that that's the golden truth. Just because a port shows is not open. For example, I did a traceroute out of here to Cisco.com, and the traceroute failed at the second hop. That doesn't mean Cisco.com is not responding. It just simply means that a device along the path is blocking ICMP. All right? That's another art form, is being able to identify different ways of identifying network components. And there are lots and lots of tools out there that can do that. Troubleshooting. As a network engineer, the middle diagram is typically what we would use. We troubleshoot from the physical layer up. As an application developer, you're probably going to use the left side, top down. You're going to troubleshoot the application. So I can just send the Nmap and say, hey, it's your problem now. Maybe. That might get you a few days of extra time without being hassled. But that always happens, right? The network guys blame the server guys, and the server guys blame the network guys. All the time that happens. All right. However, if you can prove your case with analytics and metrics and measurements, that's much better. Okay? What would be an example of doing some sort of application level troubleshooting? I try to go to a website and it fails. I try to go to Cisco.com and it fails. But if I put in the IP address instead of the name, it works. What did I just effectively troubleshoot? DNS. By eliminating that DNS resolution piece, I tested reachability, I tested routing, I tested network function, but I was able to identify that it was a DNS issue. That would be eliminating a possibility. You could also do that with a ping, but the problem with the ping is the ping only tests up to layer 3. So if a ping works, that still doesn't mean that the application is working or not working. Another very common approach to troubleshooting is called splitting the baby or divide and conquer. Here's an example. Client 1 cannot ping the host on the internet. Client 1 is on this side of the network. Here, let me do a little diagram. Client 1 is on this side of the network. The internet host is over here. And in between, we have a whole bunch of network stuff. So divide and conquer would say, okay, go to this device and try to ping that host. If I can ping that host from that device, I start troubleshooting backwards. If I can't ping the host from this device, I start troubleshooting forwards. It's a pretty common method of troubleshooting as well. Now you can apply that to the OSI stack, or you can apply it to architecture, whatever. Ping is a great tool. It's not the end-all, be-all to troubleshooting, though. Why? Excuse me. What is the limitation of troubleshooting with ping? It only tests up to layer 3, right. It doesn't always give you an accurate representation of what's actually happening on the network, especially if you're using ping to troubleshoot response times. Because ICMP datagrams don't really represent what a traditional datagram might look like. They're much smaller. We're not really using any higher level processing functions of the host. We're not going up to the application layer. All right? Now you say, Derek, that Traceroute is better. Traceroute is just another ping. So we're still only troubleshooting at layer 3. However, I understand what you're saying. Traceroute can help you identify the location of the problem, potentially, whereas ping doesn't necessarily allow you to identify the location of the problem, because ping is just identifying the reachability of a destination, whereas Traceroute allows you to identify the reachability up to a certain point as you go towards that destination. All right, well actually, I'm going to talk to you about an example of that in a minute. Everybody knows what this screen is. If you don't know what this screen is, you can leave the WebEx and don't come back. No, I'm kidding. All right. Obviously, you want to check your IP settings. All right. Now, the subnet mask. I mentioned this specifically because I ran into this actually with a customer. You know you can put whatever mask in there you want. And a client was assigning an address to a host. They didn't know what mask the network was using, so they just put in some mask. And they came back and said, I can get to some of the computers, but I can't get to other computers. Why do you suppose that was? Because the mask changes how the host decides to talk. If the network is in, if the destination is in the same network, I use ARP and I try to discover that destination. If the destination is in a different network, I ARP my gateway and I try to reach the destination through my gateway, which makes sense. So if the mask isn't set correctly, you might be able to get to some hosts, but not other hosts. ipconfig, great tool, gives you all of your configuration information. This one I tend to use actually quite a bit, especially when I'm at a hotel or I'm having to do authentication through a proxy or something like that. I'll use ipconfig flush DNS to clear out my resolver cache so that I can kickstart the proxy process over again, or restart the proxy process. Pinging the loopback, we talked about what that does. That allows me to test my protocol stack. It has nothing to do with testing the physical interfaces. We're not testing physical interfaces here. We're simply testing the protocol stack. I could disable all of my interfaces and still ping those addresses. From a router, we actually have some pretty cool things that we can do. We can do something called an extended ping. When you do an extended ping, you can specify the target IP, how many pings you're going to send, the size of the datagrams, which can be useful. By specifying the size of the datagram, you can more accurately simulate large data flows. You can specify your timeout. There are even extended commands where you can source the ping. Think about this for a second. Here's a diagram. Router, network X. And over here, network Y. I want to see if this router has the ability to route from network Y to network X. So what do? I go into the router and I ping somebody on Y. That looks like an X. Let me fix that. I ping somebody on Y. And the ping works. So, I mean, ping somebody on X. I meant to say X, right? I'm trying to go over here, right? And it works. But then I go to this client and it doesn't work. Well, a lot of people don't realize this, but when you source a ping from the router, the IP address of the ping, the source address of the ping, is the interface that the ping leaves out of. Does that make sense? When you source any traffic from a router, ping, CDP, telnet, whatever, when you source traffic from a router, in other words, you're in the command line and you're doing a ping, the source address of that ping is the IP address of the interface that the ping left from. Does that make sense? So when the ping worked, all I was testing was whether or not the router knew about how to get to X. But I wasn't testing about whether or not this router knew how to get to Y, because this router is sending the response to that interface. Does that make sense? So what you do is you have an option of specifying the source of the ping. So if I go back to my diagram here, here's network X, here's network Y. When I do my ping, I source the ping from this interface. So when the ping goes over here, I'm testing the fact that this router can now get back to Y, because I'm sourcing the ping from a Y address.
When you source it, it could only be the interface directly.
Yes, you cannot source your ping from any address. It has to be an address on that device. That's a security feature, right? They don't want you spoofing people's addresses.
Yeah. Then again, like, let's say you were able to do that, you would be able to.
Also, yeah, the reply might not come back. But you might be using a router to launch denial of service attacks, like a Smurf attack or a ping of death or something like that. Here's another interesting concept. You can set quality of service values. You can set the do not fragment bit. You can manipulate, essentially, how the packet is treated as it goes through the network. Pings might respond better if the type of service is set to 3. Whereas if you set the type of service to 0, maybe they get treated differently. The ping of death, yes. The wedding ping, yeah. Absolutely. Could you use this to test your MTU sizes? Absolutely. You can set the do not fragment bit on, and then you can start to adjust the size of your pings. As soon as you reach the maximum transmission unit length threshold, if you exceed that, the pings get dropped. If you go below that, the pings start working again. Remember that do not fragment bit says no router along the path can divide this data up into smaller pieces. So you can actually use an extended ping to test the MTU path, or the path MTU. There's a bunch of other stuff you can do with an extended ping as well. Traceroute. If you guys want to see a funny video, go out to YouTube and search on Next Gen Hacker, all one word, Next Gen Hacker 101, and watch his video on Traceroute. We don't have time, I'll put it in the chat, Next Gen Hacker 101. He'll give you it's really a joke. I mean, it's not a joke, he's actually serious, but it's pretty bad, okay? Once you see it, you'll know what I'm talking about. The video is called, just to give you an idea, the video is called How to Discover Somebody's IP Address on the Internet, okay? And he uses Traceroute to do that. But he's not talking about the routers in between. Anyway, watch the video, it's funny. So from a Cisco router, we do Traceroute. From a PC, we do Tracert, which is also Traceroute. But here's the thing about Traceroute. I already told you guys how Traceroute works, right? Do you remember how Traceroute works? Traceroute, go ahead. We're manipulating the time to live. Traceroute is a ping where the time to live value is being modified. So if I do a Traceroute from this PC, well, let's go ahead and use the one they're using, from this PC over to this PC. The first ICMP echo has a TTL value of 1. So when this router receives that packet and it decides it's going to route the packet, the TTL value gets decremented to 0, which means the packet gets killed. That router responds with, I just killed your packet. And now I've identified the first router. Then I send another ping with a TTL value of 2. It goes to the first router, goes to 1, second router to 0. That router responds with, I just killed your packet. Now think about what that means from a troubleshooting standpoint. If I do a Traceroute and I get a response from router 1 and I get a response from router 2, but I do not get a response from router 3, what are the potential issues? If I get a response from router 2, then I know that router 2 is routing that packet, because the only way the time to live is decremented is if the packet gets routed. If I don't get a response from router 3, well, it could mean a few things. It could mean that ICMP is being blocked, or it could simply mean that router 3 drops the packet. Maybe it's filtering the packet. When packets get filtered, we don't get a response saying that the packet was filtered. Now, if the router doesn't know how to route, oftentimes it will send an unreachable message back to the host. And the source of that unreachable message would be the router. So while Traceroute doesn't tell us everything, we can't make certain assumptions with Traceroute, but we can maybe test some theories with Traceroute. What if I did this Traceroute to 10.1.0.2 and I didn't get any responses. What would be a possibility if I got no response? If I didn't have a gateway set on the host, I would get a message like, I can't go there. I can't reach that destination. Here's my gateway address, right? 10.0.0.0.254. If I ping 10.0.0.0.254 and I get a response, that tells me that the link here is working, the link there is working, right? If I do a trace route to there and I don't get a response, that most likely means I don't even have the right gateway set. Maybe I accidentally typed the gateway as 253 or 252. So the packet is being routed, it's being sent, but it's being sent to the wrong address. Traceroute does not care whether the final destination is actually active. Because of the way Traceroute works, because of the way the TTLs are modified, as long as the packet's routable, I should always get a response along the path, even if the final destination is unreachable. Because Traceroute doesn't send the packet all the way to the end and come back. It sends the packet one hop at a time. All right? Show commands. Show run, we did that. Show interface, we didn't do that one yet. We'll get to that one. Show ARP, we did that. Show IP route, we did that. Show protocols, we'll do that tomorrow. Show version, we did that. Show IP interface brief. I put these commands on this slide because these are some of the most common commands that I use to troubleshoot. Show ARP doesn't really belong there, but actually it does. It does. Let me show you guys something. Okay? I'm going to connect to one of my customers' networks here. And I want to show you something that, well, to give you an idea of how troubleshooting might occur. Right? Maybe you've identified, for example, in your network that a particular host is causing a lot of problems on the network. Maybe it's generating a lot of broadcast traffic. Maybe it's, I don't know, whatever, causing some sort of issue. All right? So I might do something like this. Show ARP. All right? And let's pick one. Let's pick 231. Actually, those are all phones. Let's pick 252. Okay? So for some reason, I've identified that 252 is doing something strange on the network. Maybe I'm doing a Wireshark capture, and I'm seeing a whole bunch of stuff come from 252. So show ARP gives me, and I can even do include.252, it gives me the MAC address of the host. So I copy the MAC address of the host, and I do a show MAC address table, pipe, include the MAC address. Now I know what port that particular host is connected to, 3031. And by the way, I can also take that MAC address and do a MAC address lookup, maybe identify what type of device it is or whatnot. There are so many different troubleshooting techniques that are extremely useful, and they're such basic commands, you don't really think about them until you've run into a scenario where you actually have to troubleshoot. Finding a host on a network where it's physically plugged in if you don't have your network documented can be difficult. That makes it pretty easy. So basic show commands can easily be used to troubleshoot the network. We already talked about this concept of span. We'll talk about it again. Everybody seemed to be really interested in it. So the span feature, called port mirroring, allows me to essentially tell the device, right? In a hub, we don't have to worry about it, right? Because in a hub, anything that goes in one interface gets sent out of every other interface. But on a switch, as the switch learns, that information only gets sent from device to device. If I have some network management workstation hanging off the side of that network, it's never going to see that traffic. So span allows us to instruct the switch to start copying information to that particular destination. We might do this if this is an IPS sitting on the side of the network. Sorry, not IPS, IDS. Or if it's a Wireshark machine that we're trying to capture information with it. Surprisingly enough, this is a very easy feature to configure. We're not going to get into the advanced concepts. If you go out to Cisco.com and you search on switch port analyzer, there's about a 30 or 40 or 50-page document on this technology. I'm giving you guys the basic information. How do I configure it? Go into my switch, create a monitoring session, give it a number, specify the source interface where the traffic is going to be copied from, in this case 108. So all traffic from 108, we'll call that interface. By the way, what does the both mean? What does both mean?
Inbound and outbound.
Inbound and outbound, that's right, both directions. You could actually be selective. You could say traffic coming into that interface or traffic going out of that interface. Then I specify my monitor session destination. That's it. Literally 2 commands. All the traffic from 108 is now going to get copied to 1010, even if it's not supposed to go there. So now I can launch my Wireshark application on my desktop, and I will now see all the traffic. What if you wanted to see traffic flowing between 2 hosts? You would do a monitor source inbound here, monitor source outbound there, monitor source inbound, monitor source outbound. Now that's not just, you can't really filter it per se, but at least it gives you comparative information, right? You can compare the information you're receiving from one interface to the other interface. There are actually configuration options with Cisco where you can actually monitor ports from one switch interface on one switch and send it to a completely different switch interface across your enterprise. That's called RSPAN, remote span. All right, that is the troubleshooting chapter. Obviously very high level.